Continuing on section 2.6, feel free to pause here and give this a try if you'd like. Monetary exchange rates change from day to day. On a particular day, the exchange rate for dollars to euros was about $1 to 0.63 euros. About how many euros could you get for 325 on that day? So we have $325, that's what we're starting off with. That's the amount we know. We put that over 1. We multiply by our conversion factor. Here it tells me $1 equals 0.63 euros. I'm looking for how many euros, so that has to go on top. And I need the dollar to go on the denominator, because when we multiply fractions, we multiply straight across. And that allows us to say anything divided by itself cancels out. And that works for labels the same way it does with numbers. So dollars divided by dollars cancels out. We put in what we know. 1 goes with the dollar and 0.63 goes with the euros. So we multiply. And simplify. And we get 204.75 euros. So 325 American dollars would give us about 204.75 euros. We can also convert rates, but because rates compare measures in 2 different units, sometimes we're going to have to change both of the units. And if we have to change them both, we have to multiply by at least 2 conversion factors in order to change both of the units. So we're going to change one of them at a time. So here a student ran the 50-yard dash in 5.8 seconds. Remember, distance equals rate times time. So this is our rate that we're looking for. Divide by time, and we get distance divided by time equals rate. So here I can say 50 yards in 5.8 seconds. So right now I have yards per second. And we want to know at what speed did the student run in miles per hour. So I'm going to miles per hour. So I need yards to miles. I need to know how to compare those two. And I need seconds to hours, because I'm changing my time and my distance. So 1,760 yards equals 1 mile. And 3,600 seconds equals 1 hour. And if you're not 100% sure on that one, we know that 1 hour equals 60 minutes. And we know that 1 minute equals 60 seconds. So I can go 1 hour. 1 hour is what I start with. I'm going to minutes. So my hour cancels. And then I'm going to seconds. Remember, we're looking for seconds. So here I had to convert it twice, but it works the same way. I switched to 60 minutes, and then 1 minute is 60 seconds. So I go from 1 hour, multiply straight across, and I get 3,600 seconds is the same as 1 hour. So we could have converted it there, but this is something you're going to want to write down and store on your noggin. It's going to make it a lot easier and quicker here. So we have our 2 conversion factors. It does not matter which one you switch first. Keep in mind, though, that our final answer is going to be miles per hour. So I'm going to switch my distance first. Doesn't matter which one you do first, but that's what I'm going to do. I have yards. I'm looking for miles to be in my numerator in my final answer. So I put miles in my numerator, and I'm looking for my yards to cancel out. So in order for that to happen, I need 1 in my numerator and 1 in my denominator. I plug in my values. 1,760 is yards in 1 mile. I have miles. Perfect. Now I need to switch hours. I need hours to go in the denominator in my final label, and this is different than ones we've done before. Before, all of our rates were in the all of our labels were in the numerator, but here with rates, we're going to have some in the denominator. So my time is going to be in my denominator there. I also know that because I need seconds to cancel. And so I have to have 1 in my numerator and divided by 1 in my denominator. So 1 divided by 1, seconds divided by seconds, cancel each other out. I know it's 3,600 seconds in 1 hour. Now I can multiply straight across. In my numerator, I'm going to get 180,000. And this, all I have left is miles. Over in my denominator, 10,208. And the only label I have left here is hours. So my label checks. Miles per hour is what I'm looking for. Now we can actually simplify this by dividing and get approximately 17.6 miles per hour, or you can say mph for miles per hour. And again, they wanted us to round to the nearest tenth, so I did there. It was 17.63, and the 3 rounded down to a 6. Now feel free to pause here and give this a try if you'd like. An athlete ran a sprint of 100 feet in 3.1 seconds. At what speed was the athlete running in miles per hour? Round to the nearest mile per hour. So here, our rate is distance divided by time. I'm going from feet per second to miles per hour. So I need to switch feet to miles. 1 mile is 5,280 feet. And I need to switch seconds to hours. 1 hour is 3,600 seconds. And again, because I have 2 different labels here and I'm changing both of them, I'm changing both my distance and my time, I need to multiply by 2 conversion factors. Doesn't matter which one we change first. I'm going to do my distance first. So I have feet. I'm going to miles. I need that miles to be in my numerator. I also need feet in my denominator because when we multiply straight across, anything divided by itself cancels out, and it works the same for labels. So I have 1 mile and 5,280 feet. Then miles are good. I'm going to change my time. I have seconds in the denominator, so I need to put seconds in the numerator so that seconds divided by seconds cancel out. And because I'm looking for hours to be in my denominator, in my final label. So I need the hour to go in the denominator here. 1 hour is the same as 3,600 seconds. So again, 2 different ways we know that. We need our labels to cancel, seconds divided by seconds, feet divided by feet. So 1 in the numerator, 1 in the denominator. And the label that we have left, which right now is miles over hours, should match what we're looking for, miles over hour. We multiply straight across with fractions, so I can take 100 times 3,600. 360,000 divided by 3.1 times 5,200, 16,368, and this is hours. Last thing here is we reduce, so I can divide my values that I got here when I multiplied, and I get 21.9941,349, and this is miles per hour. It says round to the nearest mile per hour. So the 9 rounds the 1 up, so it's going to be 22 miles per hour approximately. So if an athlete runs 100 feet in 3.1 seconds, that's approximately 22 miles per hour. Quick recap here. Ratios and unit rates can be used to compare quantities. Units and rates can be converted to solve problems. And that's all I have for section 2.6.